Okay, vectors can also be used to represent velocity in navigation problems. So this is another way that we can use vectors in the real world and that they are actually applied. This is not the last way that vectors are used, but this is the last way that we're going to examine together here in this course. We do need a little bit of terminology in order to understand these problems. Heading is measured as an angle from north due clockwise. Now, this is very different from how we show our angles in mathematics. In math, normally we start at the positive x-axis and we go counterclockwise. These are saying we're going to start from north. North usually on paper is represented straight up, and then we're going to be going clockwise from there. So our angles are going to be going this direction. So it's very different measurement. Course is also an angle that's measured from due north clockwise. So with these navigation problems, they're always measured from due north clockwise. And this is actually how people talk about it when they talk about angles for vectors in actual navigation. It's measured from north. It does say unless otherwise described. So sometimes within these problems, they'll say things like 12 degrees east of north. Oh, that would be the same way. They may say 12 degrees west of north, which means you would start at north and then you would go 12 degrees to the west from there. So if they describe it differently, then you do it the way that it's described. But if they just give you an angle, from north clockwise. All right, so in aviation, there are some other terminology that we're going to be using with vectors here. There's going to be what we call the ground speed, which is the speed that the plane actually covers distance on the ground. And the way you figure that out is using the airspeed, which is the speed of the plane in the air, and you add to it the wind speed, which is the speed of the wind and the direction. These are all vectors, so they have both magnitude and direction. The magnitude on these is represented by the speed. The direction, of course, tells you which way. And because it has both of those, that would make it a velocity, which is speed and direction. All right, the heading is the angle that's measured to the airspeed vector. So the heading is related to this airspeed here. And the course is the angle measurement to the ground speed vector. So ground speed goes along with course. All right, now this may sound totally logical to you, but if you've never heard this terminology, it might be foreign. A tailwind would increase the speed of the plane, would increase the ground speed. That means that the wind is coming from behind the plane, and so it's actually pushing it faster than the engines have to work to make it go. Conversely, a headwind means that the wind is blowing against the direction that the plane is flying, and so that would decrease the ground speed of the plane. It would cover less ground than it ought to be because the wind is pushing against it. Alrighty, so here we go. For our first problem, first of all, I have a compass rose for you over here, just in case you're not so good with directions. North and south, usually everybody get those without much problem. It's the east and the west that people have a hard time with. So somebody once told me that if you have it done right, then it spells out the word we. So that kind of helped me, and maybe that'll help you too. So here we go. It says an airplane has an airspeed of 520 miles per hour on a heading of 115 degrees. Wind blows from the east at 37 miles per hour. They want to know the plane's ground speed, which is the sum of the airspeed vector and the wind speed vector. And the magnitude of that would give you the ground speed. So here we go. I'm going to start by drawing a picture. I'm going to start with a coordinate plane because it's very helpful to have that to work with. It helps keep the angles so that they make sense. So I'm going to do the airspeed in purple, I think. Okay, so the airspeed, the magnitude of it is 520, and the heading is 115. So for that, I would be starting from north, and I'm going 115 degrees clockwise. So if I go from north to east, that would be 90 degrees. And if I go from east to south, that would be another 90. So that would be 180 from north. But I want 115. So that means I need to be a little bit beyond east. Not so close to south, though. So here we go. I'm going to make that one kind of long also because, well, it's supposed to have a magnitude of 520. That should have been purple. There we go. So I'm going to go ahead and label that as 520 miles per hour. I'm also going to label the angle that we used there. That angle right there was 115 degrees. Alrighty. Now I'm going to put in the wind vector, the wind speed vector. And I think I'm going to do that one in light blue. Okay, so it says that the wind blows from the east. So if it is blowing from the east, that means it must be blowing this direction. Oops. Which would be toward the west. So when I draw in this vector, I need to draw it toward the west. And I'm going to label that one with 37. The magnitude of that one is 37 miles per hour. Now with that one, they did not give me an angle because it is blowing to the west. So I don't really need an angle. If I did need one from due north, I could say that that's negative 90, or I could say it's a positive 270 degrees. Anyhow, I need to add these two vectors together so I can find my ground speed vector. So I'm going to add that by adding on this little wind speed vector onto the end of my airspeed vector. So I'm reproducing that one. I'm trying to make it look like it's about the same length. I'm going to label it with 37 because it has the same magnitude as it did when I drew it up there. And then I need to put in my ground speed vector. I think I'm going to do ground speed in pink. So that would be from the start of the first vector from the tail of the first vector to the head of the second one. Okay, and I show the direction there. This one here is going to be my ground speed. I'm going to call it G for ground speed. Okay, now with this one, I've got two sides, and I don't have any of the angles so far. The angle that I would really like to get is this one that's across from the ground speed vector, across the triangle from that ground speed vector. So I'm going to see if I can use any information from my picture here to help me get that angle. Now I see on my picture here that the one angle that I do know is 115 degrees. And with that, I can actually figure out what this angle is right here because it's past 90 degrees. So if I took out this right angle here, this 90 degrees, then that would tell me that this angle right there is, let's see, 10, 25 degrees. Now that one's helpful because that one and the angle that I actually want are alternate interior angles on parallel lines there, which means they're congruent. So that one is 25 degrees as well. Okay, so now to find the G, the ground speed, the magnitude of the ground speed vector, I can use the law of cosines again. So I'm going to go ahead and set that up. G squared is equal to Then the other two sides of the triangle would be my other values there. So 520 squared plus 37 squared minus 2 times 520 times 37 cosine of 25 degrees. I kind of ran into my compass there. Okay, I'm going to solve this. When I solve it, I'm solving it for g, not for g squared. So I need to make sure I take the square root. Hopefully I can get rid of that. There we go. Take the square root when I put it in my calculator. So I'll put all of that in there and take the square roots. And I'm going to have to type that in. I'm not as good at typing on a touchscreen calculator as I am on the one with the physical buttons. So it takes me a little while. Okay, so for that one, for the ground speed, I got 486.718. Okay, so just a quick note, I want to make sure that my answer makes sense here because having answers that make sense is rather important. So if I look at this one here, the ground speed on this one is less than the airspeed. Now my airspeed was 520, and what would cause it to be less is if the wind was blowing against the direction of the airplane. So looking at my picture here, the airplane is heading toward the southeast and the wind is blowing toward the west. So that means the wind is blowing against the airplane, so it should slow it down. So this is a sensible value. Now, if I go up and look here, it actually says that we want the ground speed to the nearest mile per hour. So when I presented this as an answer, I would actually say that the ground speed is approximately 487 miles per hour. But I included more decimals than that because I'm going to need this value in order to in order to find the next piece of information, the course. Okay, so going back to my picture now, I'm going to need another color. I think I'm going to use yellow. The course is going to be this angle here that's going from north to my ground speed vector, so all the way over to that pink one there. This is what I'm looking for. So that's my course. Now, in order to find that, I know that to the purple one, it's 115 degrees. And then I can use that plus the little angle. I don't have a good color to use here. Plus the little angle that's inside here to find the total course. So I think I'm going to call the course, well, I'll just call it course. I'm going to make a plan for how to find it now. So my course is going to be 115 degrees. And then I want to add to that little bitty angle right there. So I'm going to call that angle something else. I think I'll use a Greek letter. I'm going to call it alpha. You can use whatever you want to. So if you don't like Greek, you can use Chinese characters. I'm just kidding. Okay, so now we need to find alpha. Alpha is inside the triangle where we know now all three sides of it. One of them is approximated, but like when we were doing the law of cosines and solving our triangles, we don't have a choice. We have to use that approximation in order to find what we need here. So I'm looking for that angle right there. So that angle is alpha. We're going to call it alpha. And with law of cosines, we said we used cosine of alpha equals, and then we made a big fraction. and that big fraction, we had minus, and then the side that went along with our angle that we were looking for is the one that went after the minus sign. So I'm going to put 37 squared over there. Now everything else is going to be the other values that are in here. So I'd have 520 squared, and then the other one was 486.718 squared. That was my G. Then on the bottom, 520, and then 486.718. And then when I go to put this in my calculator again, I have to solve for alpha, not cosine of alpha. So once I get all of this over here, I'm going to need the inverse cosine of that value. So let's take a moment and get all of that in the calculator now. I'm going to press clear a few times just to make sure I don't have anything bad included in there. Okay, and in my calculator, I got 1.841 degrees, approximated to 3 decimals. When I go back and read the problem, though, it does say that we want the course to the nearest degree. So if I was going to approximate this to the nearest degree, that would be a 2. Now I'll take that back up and apply it to my formula for course, because remember, we only found alpha just now. We did not find the course. Our plan for the course was 115 degrees, and then we were going to add to it whatever we had for alpha, which was 2 degrees. So my course then would be 117 degrees. Okay, so now there are a couple of questions on the Google form for you to try. Of course, you're welcome to watch this video again if you need to see all that happen again, but then try the one on the Google form and see how you did.